Okay, welcome back. It's another week. It's another lecture in computing technology. Let's just have a look at our web page to orient ourselves. Now, if we just click on the syllabus over here, I'm going to make this a little bit bigger for everybody to see. Let's look back at where we've been, where we are, and where we're going. Let's do that real quick before we begin. It's week 7 this week. We're down here, and this is an exciting week. As everyone knows, we've been spending the last several weeks on the C programming language. Some love it, some don't love it, let's put it that way. But, you know, I've rarely met anyone who doesn't just love to use Python, and myself included. I'm real excited about this week because we'll be dipping in and out of Python for the rest of the module, and most people will implement Python heavily for their final project. What we've been doing so far is introducing programming concepts, and someone asked in class this week about why we bother using C at all. And the short answer is that if we think about all the programming languages that are out there, and listen, there are thousands of programming languages over the years that have been created. Thankfully, there are only about a dozen or so that are used for almost all the work that people do, and maybe a few specialty languages. C is one of the most important foundational languages of all the most popular programming languages today. And in that range of languages out there, there are some that are referred to as low-level languages that are closer to machine language, closer to the, at the very extreme, ones and zeros. And if we click up a few clicks, the programming language itself implements structures that are distant from human language, maybe closer to computer language. And then high-level languages are ones like we're used to using every day, like R and like Python, that their way of programming is to implement code that is very similar to a descriptive human language, maybe even much, much closer to pseudocode we might use to design a script or a program. Well, C is definitely on the side of the scale towards a low-level programming language. And what we've been talking about recently are ways to define data structures, ways to manage memory, ways to allocate, and little tricks to manage data structures with memory pointers. We talked about the basics of algorithms. We talked about libraries. We talked about in addition to those custom data structures, we built those with the foundational data structures and all those data types. And we've just been practicing. And that leads me to another comment I want to make. I realize that some people have been working very hard in here. And trust me, one, I noticed that. I know who you are. I know who's been working really hard in here. And let me thank you. Thank you so much for participating in this module. I mean, I don't have to thank you because the person that benefits the most is yourself. The people who have been working the hardest are going to find the rest of the module a complete breeze to get through because for example, this week, what we're doing is translating a lot of the programs and algorithms that we've already written in Python, and we're translating them in C rather. We're translating them into Python. And one thing that's going to become immediately apparent is that a program that you write in C will tend to be much, much shorter and easier to write in Python. Why is that? Well, we'll talk about that in lecture today, but in a nutshell, it's because the syntax is closer to human language. It's because a lot of the things that we have done manually, by writing code in that low-level programming language C, are implemented either dynamically, automatically for us, or there are very simplistic tools and rules for us to exploit in Python to do the same amount of work with much less code. All right, so if you feel like you've been working very hard and you're concerned about the rest of the module and maybe your other modules, try to put that aside, because it will get easier and it will be faster building on the work you've invested so far. So thanks for that. All right, so what are we doing after this week? Well, after this week, we'll touch on a few special topics. So we just have to touch on SQL, the most popular programming language to manipulate databases. We're going to touch on a little bit of web programming, the basics. Some of you will have seen some of this before. Hopefully there's something in there for everyone. Some of you might be new, but basically we're going to be talking about how the internet works and how to do it ourselves. Then in week 10, we will talk about a system that's implemented in Python called Flask that runs web servers. And, we'll be doing this on local web servers here, but it's going to avoid the need to use external tools. If we're doing any sort of web serving, which most people will be for their final project, you'll be using Flask. There would have to be an extraordinarily good reason to use anything other than the system we're talking about in our class. And to be honest, I can't think of a single reason that would hit that mark. And then that's a wrap up for the module. Okay, that takes us through the next couple of weeks. If you want to follow along today, we're going to go through the lecture. You can find the lecture link here. Of course, you'll be responsible for the notes. All the code is linked to here. And, of course, we have a couple of tutorials. We'll just take a peek at them. And the Python tutorials for this week are, it's just the one going through Python syntax. And then finally, we have the problem set. Let's just peek at that real quick. And there are a couple of them. Now, I hope these problem set titles look familiar to you, because you are literally just going to re-implement some ones we've done in the past in C. And I know if you go through the examples in the notes and in the guidance in these problem sets, it will go much faster and the code will be much shorter. So I hope you enjoy doing that. It should be fun to cash in on some of the investment you've made. Without further ado, I want to go ahead and start with the lecture. Right, so Python is one of my favorite programming languages. Maybe it's up there with R. R is my real comfort spot, but I love using Python. It's so fun, and I know you'll find it fun as well if you haven't already used it. So we're starting a new language, obviously, this week. It's more on the high level towards human language. Most people prefer that when they're coding. Most people are more productive. Most people find it faster. One of the reasons Python is so popular these days is something that it does exist in C, but it is another planet the way it's implemented in Python, and that is the ecosystem of packages that are very, very popular to use in the Python programming languages. So this is thousands and thousands of people across the world contributing tools that they build and then they share immediately for free with everyone. And another thing I want to say about this week before we begin is that what are we doing here? Well, we've learned some of the basics of algorithms and the concepts of data structure, the concept of storage and memory and how computers manage that. We've explicitly done that ourselves in C. That's the whole point of doing C for the first few weeks. Now we're going to implement those same concepts. We're not adding any new concepts this week at all. And really for the next few weeks, we're not adding a lot of new concepts other than new tools to do certain things. This creates incredible flexibility. Now, learning a new language is considered by some. I mean, it's common to hear the language, should I learn Java? Should I learn MATLAB? Should I learn R? Should I learn Python? Well, to somebody who's programmed for a while, no matter who they are, these are a bit silly questions to ask. And the reason for that is if you program for any time at all, there's going to be a new popular kid on the block. And most people who do this kind of work professionally in any capacity are going to learn new languages fairly often. Whether they learn them to a very great depth and become experts, that's another story. But the most popular language changes from time to time. It depends partly on what you're doing in your career, but it also depends on trends and developments in the field. So what I'm trying to say is that there's this continual process of learning, and this is a taste of that. We're just extending what we've already learned. We've already learned the concepts in one language. We're just extending them to another. Actually, we've learned many of these concepts in two programming languages already, one Scratch, two C, and now we're extending them to Python. And I think most of you will like it and find it fairly simple. So we're going to have some examples where I compare Scratch to C to Python. So we might have a Scratch structure like this, where there's an action that when clicked, we get some output called hello world, right? This is something we implemented. And we also saw this in C, our very first program, the most program for most people in most programming languages. For this, we we implemented a header that had the standard input-output, int main void, curly braces, and then we used the function printf to print hello world in double quotes, and we wanted to specify a new line at the end, and we also use a semicolon at the end of computable lines. All right, so this is how we implemented the Scratch program hello world in C. Well, here's how we implement it in Python. It's a much higher level language. It's many fewer lines than in C. We have a function, not printf, but just print. Still have the double quotes. We have hello world. What am I doing here? Looking for my pen. There we go. And we don't have a semicolon at the end of the line here. All right. Now, when we went to compile and run a C program, we did it like this. If we had hello.c, we would use a make file to specify make hello, and then to run it, we would run the compiled program with /hello. We talked through this already. What's happening behind the scenes is that we're using this compiler, Clang. We're specifying a command line output with a -O flag. We are specifying the output file name to be hello. We are specifying the target name for compilation to be hello.c, and we are linking the header that we called, if we used the CS50 header with this -L flag, and then the call to execute the executable. In Python, this is a completely different scenario. It is much easier. Here we invoke Python as a command, and we name the file. By convention, Python code files are specified with the .py extension. Now, the difference between C here is that C is a so-called compiled language. Give me my C back. There we go. Whereas Python is a so-called interpreted language. And what that means is that for C, as we discussed in past weeks, we took the code, we went through this compilation step to translate our relatively human-sounding C code into ones and zeros that were executable, and then another step to actually execute it. Python is a system that interprets our code on the fly and creates the output without the need for a compilation step. So it is quite different. Now you could look back at and if you look in the notes, we compare the dictionary.c code to the dictionary.py code, and you'll see the difference in just the length of the code, but the structure will be just the same. And you could also look at blur.py that we did a few weeks ago in C. This is in the notes that I go through, so you should have a look at those. All right, so I already went over compiled versus interpreted. What we're going to talk about now is functions, how we call them, what they work, and a little bit of the differences and intricacies of calling them in Python. I say intricacies, but actually it's very simple in some ways compared to C. All right, so in Scratch, if we wanted to say hello world, and we had the printf function like we went through before with the double quotes, the end of line demarcation to make a new line, and the semicolon. And we already looked at at how that's implemented in Python. In a way, it's just much simpler. They've also, there are these decisions that the designers of programming languages make there's always a pursuit to make the use of their language simpler, to make it more efficient, to make it easier to use, and even to make it fun to use. And, just a very minor example of that is the relatively kind of weird formatting of printf. You have to think through that and get used to it, and then it just becomes normal. But they just decided to print, to use just the print function. And there is a way to use a formatted code, which we'll look at later in this lecture, but they just left the print function named print. So no semicolon, no new line. We'll see that we get a new line for free by default, and no printf. Now, we used headers in C to exploit tools and functions that other people had prepared and written for us for common things that, lots of people would use with lots of programs that they write, just to be more efficient. And the equivalent of that in Python is called modules or packages. So we can use those names just interchangeably for now. And the way that we would declare our utilization of a such a tool set, a header in C, was we'd use the !include and then name the header file in between the less than and greater than brackets. But in Python, it's very easy. Again, it's slightly simpler. We just use the import keyword, and we name the module or the library we're importing. This would import the whole library. It's also very popular, especially for big libraries, and some of them are very big, and we'll start using some of them quite soon, some of the big libraries. If you only need one or two functions from a library that otherwise is quite big, to save time, to save for the sake of efficiency, we could use syntax like this. From the CS50 module, we import the function getString. Okay, so it's an alternative syntax to just grab an individual function. And there are other syntactic ways that we can do things. And that reminds me to just make a comment here about something that is I'm going to say it first. It's an advantage in modern programming languages, and that's the flexibility of syntax. There are multiple ways to do the same thing that are valid, and maybe some of them are better in some situations, but for many of them, there are just multiple ways to accomplish the same thing. That is a big advantage. Because different people have different preferences. Different people have different styles of programming. This flexibility, though, I will say, can be it imposes a little bit of a challenge for learners, because while you're trying to learn something and discover a solution, maybe you're trying to discover a particular solution that is better than others. But if you try to get help, let's say from the internet or even from other people, you may get several different answers to the same question. So there is a bit of a cost to this flexibility, but overall there's a great consensus that the flexibility is more beneficial than the slight learning curve at the beginning. All right, so we're going to look at a few examples here. This is an example of a program we wrote in Scratch and in C, where there is a question that's asked, what's your name? User input is required, and then we put that answer to what's your name here in a variable called answer, and we say fantastic, then print out hello, whoever your name is. The way we implemented that in C was that we declared a string and called it answer. We used the getString function in the CS50 library, made a prompt for the user, and then used printf hello. Had to include a variable for the percent string indicates to expect a variable that is a string, and then new line, and finally we put the variable name semicolon. Okay, so this is the way we implemented it in C, and here's what it would look like in Python. At least here's one of the ways it could look in Python. Here we declare our answer. Notice we don't declare the class of the variable type. We use get_string. Guess what? There's a CS50 module for Python as well. We give the user prompt, and here we just use the plain old print function. Here we have a string hello, comma, space, close commas with a plus sign and answer, adding our variable. And what this will do is print out the answer that is the user input for their name. But you know, it's very similar to what it is, but there is a variant. Keep your eye right in this area when I switch slides. 3, 2, 1. Notice that we no longer have a space here, and we've replaced the plus sign with a comma. Well, it turns out that the plus sign concatenates different inputs. It just joins them together. It adds them together with a string, and it explicitly adds them together, including spaces. And if you fail to put a space, there won't be a space. Whereas the print function itself, as we'll see in a second, by default, if we do not use concatenate, if we just join things that we want printed separated by commas in the function brackets, it will automatically add a single space between items that we pass. Okay, so this is an alternative way to get exactly the same output. And I mentioned that there is a way to use format code. We use printf to format a string in C, but here we use what some people call an F string, where we use the keyword F and then put it next to a string. And here you can also see that there's a string in quotes, the hello and the comma and space, but in curly braces, we've also got an answer that is a variable that will just be added to this space, and that's what the F string keyword allows us to do. So this is 3 ways now. All are very good ways, all are correct to do exactly the same thing. And I have to say that this one looks a bit weirder. It looks a little bit closer to C language, maybe a little bit further from human language, but it's very common to have dynamic answers that we manage through variables. It's useful just in the same way that it's useful in C. Let's see. Okay, the next thing that I want to, I just wanted to say that you can check these out in the code this week with the hello.py ones, and there's different versions, 1, 2, and 3 that I go through in the notes, so check those out. Okay, so we have a concept I just want to run by you, where there are positional parameters that have a particular maybe an order that you pass them, and an example of this would be the components of a string that you pass to the print function in Python. But something I just want to highlight to you is the idea that there are named parameters inside of functions, and the idea for this would be like print, and there might be an argument 1, argument 2, etc. And these are so-called named parameters inside of a function. And what happens is you would provide, if you want to alter the behavior of the function, you would provide the name of the argument that's built into that function and provide it with a value. And many of them have default values, as you'll see. So if you just randomly Google on the internet, you will find so many dictionaries, cheat sheets, documentation, blog posts for Python, right? But let me just give you a piece of advice. Don't bother Googling. Don't bother, if you want to become good at this stuff, don't bother using AI. You'll get a different answer every time. You'll have to hunt and peck for your answer. Cut to the chase and go to the official documentation. Do this for any tool set that you use, because that's the definitive answer. And the ones for Python are at this URL. They're very good. Everybody who's a real programmer would only consider going to this documentation if they want to really get something right and commit it to memory. And there's a folder in it for libraries, and a whole page of many functions. And of course, on that functions page is a page for print. Now, I recommend just to hunt and peck around there and go to the print section, download the lecture and follow this URL, or you could type it in. And what you'll see is a definition of the print function for Python in there. And you'll see these named parameters in there. And it looks something like this. And what this one looks like, this one's the only funny one that's got an asterisk. Let me tell you the first thing, in case you tense up when you see this. This asterisk has nothing whatsoever to do with pointers or memory or anything like that. Instead, what it denotes, and you can read about this yourself in the documents, is that this is a default argument that could contain one or more values. And so it reflects the fact that you could pass several arguments that themselves are objects separated by commas. And then we have a named parameter called sep, and we see the default. What you see in the documentation is the default value of these named parameters. So objects doesn't have any default value. There's no equal set to, but sep does, and the default is a single space. That's why we get that single space for free if we don't use the concatenate operator. We have a named parameter called end that has the \n. Why is that by default in the print function in Python, where we have to add it manually for every program in C? Well, the designers of Python said that they asked the question in reverse. Why are we bothering adding the same exact thing to every single line we write where we print something? Let's just make that the default. By manipulating this value in the named argument, you could change it. You could change it to something different or add more to it in single quotes. And, we might address file and flush in the future, but we can leave those for now. They have default values and they'll be fine for us for this whole module. Another little thing, a syntactic thing that I want to point out is the use of single quotes inside functions and double quotes outside functions. This is just a convention in Python, whereas they did have special meaning in C. You'll recall, but in Python they can be used interchangeably, but by convention we use single quotes inside functions and double quotes outside functions for strings. All right, so I went through the different components, the different named arguments for those, and now we're going to talk about variables and how those differ. So in Scratch, we might have had something like this, set counter to some value. And in C, we might declare and initialize an integer by declaring the class, giving it a name, setting it to an initial value, semicolon. This is how it looks in Python. Counter equal to 0. The assignment operator is exactly the same. It's just a little bit simpler syntax. When we increment these different variables, remember in C, we had this kind of weird syntax where counter equal counter plus 1, semicolon. It's a little bit counterintuitive, remember, because programming languages evaluate on the right and then assign to the left. So this is correct. And in Python, it looks very similar, exactly the same, except without the semicolon. There were different ways, you remember, to do that in C. So one of the ways that we can use in Python, we use this similar syntax, the plus equal operator, to increment counter itself by 1. And 1 is missing, though. We don't use the counter plus plus or counter minus minus in Python. Types. Now, we had a lot of types in C. And just to pick on a couple out of the lineup here, we had double paired with float and int paired with long. And remember, we even had a long. And a lot of these were to do with managing memory, which C required us to set aside a certain amount of memory for the variables we declared. In Python, this overlaps, but it's simpler. One of the reasons it's simpler simpler is we don't have to allocate memory ourselves. That's allocated dynamically behind the scenes. Now this is a lot easier to use, most people find, but some people don't prefer it, believe it or not, because it leaves the memory management up to the computing program. And there are ways to manage memory where we might cover it in future modules. We're not going to do it here, but most people find this much, much simpler. There actually are some specialized classes in Python. Some of them we're going to use, and a lot of these serve the same kind of function as different classes of structs that we made in C. So, one example is the dict variable type here that, we created our own dictionary with paired values, and there's already a variable type. It's so simple to do. So a lot of people, again, find this much simpler to use because they don't have to recreate the wheel. Everything's 100% consistent all the time. So we'll touch on some of these. Likewise, we had these helper functions in the CS50.h for C, and some of them had, variance depending on how much memory we had to set aside. And guess what? In the CS50 Python library or module, it's also simpler, just to reflect that. How would we get a hold of those in Python? Well, the easiest way would be to use that from import pair of keywords. So from CS50 import get underscore float. And, we do that for the ones that we wanted. Of course, if for some reason we were writing a program that needed all of them, you could do it just in the same line and separate the functions you want to import by a comma. It's quite nice. Next concept is conditionals. So if then, if else, and so forth. So if x is less than y, then say x is less than y. Implemented that in C as such with the if function, the Boolean expression in brackets, curly braces, printf, and then x is less than y, backscore in with a semicolon. In Python, we have a little bit of a different syntax here. Simpler, no semicolon, no \n, no printf, but print. And here the syntax is a little bit different for the if. Notice the colon. And the thing I really want to point out is this indentation here. It's simpler in Python, but in Python, unlike C we could just, syntactically there was style where we would structure and indent our code, but in Python that's mandatory. So just be aware of that. If you're using an editor and you've named your file .python, the indentation will, most modern editors will indicate whether or not you've got the indentation right. It's 4 spaces. All right, so let's look at an if-else. That's what it looked like in Scratch. And in Python, we're growing our code here, where we've got our if, and we've got our else, which is structured exactly like the if statement with an alternative printed output. And, I would think that you would be able to anticipate the pattern here. So here we just add an else colon with an indentation space and then an alternative print function. And we also had if then else. And in C we implemented this with else if. Okay, so it was if, this, else if, another Boolean in our output, else is our final statement, and then a final output for the other alternatives. How do we do this in Python? Well, there's a little weird one here. Again, a lot of people become used to it and then just like it, myself included, is to implement the else if. We use a single word, elif, E-L-I-F. So we have the initial if, the output, the elif, print, and then the final else. Okay, so we have the str that does a lot of stuff. We compared strings in C, and to do that we created our own struct and had some tools in the cs50.h that we used. And for this one, I'm just going to let you go through the notes. You can look in the compare.py. If you go back and look at the notes from the other one, well, you'll see in the notes for this week that how the built-in string function differs in C for comparing strings. Remember, we had that business with the it wasn't straightforward to compare strings because some of the array that comprised in a string contained pointers. So we had to jump through a few hoops, but you'll see in Python that it just works like you would hope and expect it to do. And you can check out the agree scripts for this week as well. So check out the notes and examples for those. Now, I'm sure some of you have encountered the phrase object-oriented programming, but you know, what does this actually mean? Well, in C, we had structs that we made, and those structs were associated with particular kinds of data, and they were meant for certain kinds of jobs. Well, in object-oriented programming, the use of specific data structures is not notional. It's a central part of the style of and many modern programming languages fully embrace this. It's referred to as OOP, and it basically is the case where a particular class or data structure is associated with a particular kind of data and function. We'll go through many examples of this. I mean, this isn't going to hammer in the concept of object-oriented programming. As a matter of fact, as an applied programmer myself, I would question really hammering the concept of object-oriented programming as a kind of innovation, because it's ubiquitous these days, and so it just is a thing. It's not a new thing to change your thinking on. But anyway, that's a bit of a high level comment I just made, which you can ignore. I would recommend that you check out the Python docs for the standard types section and look at the string methods, and ones in code that you can run yourself and pay attention to in the notes. In particular, would be the agree2.py and the copy.py. And there are a couple of versions of uppercase. And what you'll see is there are some objects. And I'll just just give you a heads up here. Let's say that you've got a string in an object called S. Remember, we had the strings S and F in C programs in past weeks. What an object in C allows you to do is you've got a particular class of data here, and we've arbitrarily given it a name S, and then you have an object associated with that might do some work for you, like change to uppercase or lowercase. Well, if you implement dot lower, the object lower gets applied to the data object in your name. Now, this is how, at least one way that object-oriented programming is implemented in Python. And let me tell you, once you get the hang of calling these objects and associated with certain data types, you will never want to ever program in any other kind of language because they are so convenient. So again, there's a little cost of the learning curve to wrap your head around this new thing in Python, but it's going to make it a lot easier. And just for example, if you were really wanting to do it and go back in past weeks when we had the uppercase, the copy, and the agree scripts in C, and I mean, if you did nothing else, just look at how many lines are in those scripts compared to the lines in the Python scripts. You'll be astonished. That's why this is a thing. That's why I mention it. Since we're naming the things that I love about Python, let's talk about loops. So in Scratch, we wanted to repeat something. Here we repeated it 3 times. And the thing we wanted to repeat was the string meow. Well, in C, we would declare the counter integer with a variable name like I and set it with an initialized value to 0, and then use a while loop. So here, while I is less than 3, so we're going to go through 0, 1, and 2. We're going to printf meow \n. It'll print meow on 3 different spaces, and after each go, I++ to increment the counter variable. What does it look like in Python? Well, it still does take a few lines, but a lot of people would say that this looks a bit simpler. We still initialize our variable. We still use while, which is nice. And here that colon syntax with proper indentation. So print and the increment of I belongs to the while loop there. Okay, so we also had for loops. This is what it looked like in C. So for int I equals 0, we initialize that on the fly. While in implicit while I is less than 3, so a condition. And then the increment built right in, I++. And this is, man, this looks familiar to my eyes. And to a lot of programmers, it would definitely look familiar because you use things like this so much. And then we just do the work. So the for loop is quite efficient and popular, and it is even a little simpler in Python. We do, in this one, we declare that for I in, and then we create an array of values. So for I in 0, 1, and 2, in this case in square brackets, print meow. Now this works perfectly fine. You'll see it gives exactly the same output as that C program, but there's a problem if you think about it, because what if I wanted to do some step of something? I probably wouldn't want to do this with printing the string meow, but you could probably, without too much trouble, think of some situations where you wanted to perform some work and you wanted to do it a lot more times than just 3, maybe even thousands or more times. And that starts to become a problem for declaring these variables explicitly. And so the way we do this in Python is we do for I in range 3. And that gives us the range from 0 to 2. Now the syntax of this is a bit weird. The range of 3 gives us 0, 1, and 2. But that's the syntax. That's how it works, and you just have to get used to it, and it won't take you long. There's another little syntactic thing that pops up that is a common thing in modern language, although unless you're a professional programmer, maybe this is less common, but for professional programmers, this is pretty common. And it's a stylistic difference. This code is equivalent to the code I just showed you, where we have I in range 3, and here's for underscore in range 3. Well, you can name that counter variable anything you want. You could name it I. You could name it underscore. You could name it Bob. All right, it doesn't matter. The thing is that in this program, in this little snippet of code here, the actual name of the counter doesn't appear. And where you have the case that a counter is purely a counter, like in this Python code where it's implicit, it's just operating at the level of the for loop itself, and it has no role in the code itself to do any work for you. Well, in that case, why even give it a name? Let's just give it the underscore. It stays local, and we never declare it. And this is a purely stylistic thing, to use the underscore in a situation where you don't call the counter variable explicitly, like in this code here. Now I've made a mistake by slightly hitting the wrong thing, but yeah, there we go. All right. So wanted to show one more thing, that we have this thing we called a forever loop in Scratch, and in Python we used while with just a condition that was constant. So this will create a program that we would have to break with Control C, just an infinite loop. Sometimes we want infinite loops in our programs, and the meow, printing meow is a stupid one, but sometimes we want that. And this is just how we do it in Python, with just while and then the condition. All right. Thing we talked about, I'm not going to go through this in detail. I'm going to leave this to you to go through in the notes, but I'm going to make a point here about floating point math. Maybe the words will come, and there they are. So what we found in C, if we took int 1 or int I equals 1, and we took int j equals 3, and then we performed the calculation 1 over 3, that we'd have truncation of the value. And just verbally going to say that the reason for that, we talked about this, was that there was this explicit declaration of variables, and the math that you do on variables, unless you went some extra steps to account for this, would stay within the class type. So you couldn't get a decimal value by just dividing two integers. But in Python, this is dynamic, and the interpreter will say, oh, you want to divide these two integers, and there's a decimal value. I bet you want the decimal value, and it will return a decimal value. Okay, so division with ints and floats, the mathematical outcome has no truncation in Python. again, many people just find that easier and more logical, and it definitely reduces the code you need and the amount of mental hurdles you go through. So, we refer to that phenomenon as floating point imprecision, something to be aware of. And so you can check out calculator 3. .py and the notes to go through some examples there. Another thing that I would say is that you get an error, an exception error when you try something squirrely without being explicit in C. And again, this is handled dynamically in Python. Okay, so there are some examples in the notes, and I hope this looks familiar to you. We had the code Mario.c, and guess what? Now we have Mario 0 and 1 .py that I want you to check out and read the notes about. And what we're going to learn is just the syntax to print out blocks on different lines and blocks in a row. This is Mario 2 and 3. And then blocks in different structures like the pyramid. And guess what? The C pyramid program that you wrote is one of the assignment components this week. One of the problems in the problem set is to just implement that program in Python. So I'm going to let you look at the notes for that. Lists in Python. Well, you'll probably be very happy to hear that we don't have to manage our own linked lists or create structs anymore. All lists of stuff are linked lists in Python. So that happens under the hood, under the bonnet. You might check out sequence data types on the standard types page in the official documentation. Probably find that interesting to look, and there's some additional detail in the notes. Likewise, len to discover information about the length of lists and tuples and other data types. You can check that out. And again, there's documentation and some detail in the notes. And ones to particularly look at would be the scores. And there's a couple of them. You should run these anyway. This will go much faster than in the past because I think the code will be familiar to you since you already looked at version of it in C, but the code is so much simpler to understand in Python for most people once you get used to it. So let me know how you get on with it, how you feel about it. Some of you have probably used Python before already. So check out the scores and the phone book code versions. I mentioned there was already a dict data class. That's a data structure that we had to create for ourselves, just to remind you that the structure of a dictionary is something that's got some kind of key expression that is paired to some kind of value. And, what we looked at in our phone book examples was some name with, with some number. So we have that built in Python, which is totally awesome. And so, there is special syntax that you have to learn. But once you learn it, it is quite intuitive and quite easy to use in Python. And we will be exploiting it by re-implementing some of the things we used dictionaries for in the past. This one's a special one. The sys functionality is something that has to do with system variables, and it has to do with the behavior of of the system that you're using this interpreted language in. And remember, different people have different systems, and some, for example, may have Linux, some may have Mac, some may have Windows. And within those different operating systems, they may have systems that are different versions. Some people will be might still be using Windows 10, or may use an older Mac version and haven't paid top bucks to upgrade. In which case, in certain cases, you're going to want to manipulate system variables so that the environment behaves in a particular way, or that it works at all for some syntax. So that's something that is a little bit of extra detail to be aware of, but it's worth doing, because ultimately this just makes your life much, much easier when you're using these. So Python is, some people would say it's a more complicated language than C. And one of the reasons for that is this large ecosystem of packages, and you have to get the versions of Python correctly aligned with the versions of the packages that you're using. This can be a bit of a problem, but the sys variables play a role in that. We talked about ways already in C of reading in data from files, and one that we'll use in Python is the comma-separated values file type functions. And so I'll let you look at that and look in the notes for detail. And then finally, there's a management system in Python for managing all those libraries and packages dynamically. Now in C, you need to install that stuff and have those headers available. There are some methods, I haven't used them a lot myself, to draw them in and download them on the fly, but ultimately you need to take care of that explicitly in C. In Python, there's also a way to do that explicitly if you need a tool, and there are so many of them that you couldn't have all of them ready, and you wouldn't want them all taking up that hard drive space, most of which you'd never use. So pip is one of the popular library management tools, and we'll look at using that in our programs. We use it with the syntax usually like pip install package, where the package is just the name of the package. So you could check out, if you want some examples of this in the code, the moo code, which makes ASCII art. If you didn't see that one in the past one, you can see pip for installing the package that lets you run moo. And believe it or not, that's all I have this week. That's all I have about Python, and that's all I have to say about that. I'll see you in class.